Hello, so today's lesson is going to be on special pairs of angles. Remember, a pair means two things. And the angles we're going to be talking about are the first one is vertical angles. Vertical angles are two angles whose sides are opposite rays. Okay, so two angles whose sides are opposite rays. So let's think about that. If I draw two opposite rays, so there's an opposite ray, and there's another set of opposite rays, okay? If I draw two angles whose sides are opposite rays, and I label, how about we do this? 1, 2, 3, and 4. Angle 1 and 2 are vertical angles, and angle 3 and angle 4 are vertical angles. See, the sides of angle 3 and the sides of angle 4 are opposite rays, okay, because these are their sides. Same with 1 and 2. All right, a linear pair, so linear pair angles, linear pair, so two angles, so pair is two, that create a line. It's actually a pair of adjacent angles. There's that word adjacent again, meaning right next to each other. Two adjacent angles, a pair of adjacent angles that form a straight angle. Remember, a straight angle has a measure of 180 degrees. All right, so linear pair angles may look something like this. There's an angle, and there's an angle. I'll call that angle 3 and angle 4. And so hopefully you're seeing that angle 3 and angle 4 together create that straight angle, that horizon or that sunshine that we've been looking for. In this picture, 2 and 3 actually create a straight angle, so those would be a linear pair. 3 and 1 would be a linear pair, and 1 and 4 would be a linear pair. All right, so how do we use these angles? Well, today in class we practiced a little bit with vertical angles and we learned some things. But the vertical angle theorem says that vertical angles are congruent. That means equal. So if I give you two vertical angles, and I can see they're vertical angles because their sides are opposite rays. There's one side and another side that are opposite rays. They're congruent, so I actually go ahead and I mark them congruent. I put angle measures through them and the hash marks. So I can use that idea to find the value of x. I can actually, if they're congruent, they're equal, I can write an equation stating that they're equal. So 3x plus 15 equals 75. All right, now I'm going to use that algebra. I'm going to balance the equation by subtracting 15 on both sides. That will give me 3x equals 60. And then I'm going to divide by 3. All right, so 3 goes into 60. What is that? 20 times? All right, and I can always check myself using that algebra you learned last year. You could plug in x for 20 or 20 for x, and then do 3 times 20 plus 15. Does it equal 75? All right, so that's how we use the vertical angle theorem. It's probably going to be one of the ones we use the most this year. Second most used is going to be the linear pair postulate. The linear pair postulate. The linear pair postulate says that if two angles form a linear pair, then their sum is 180. So I basically can say like in this I could say that like this angle here and this angle here, if I added them together, they equal 180 degrees. And so let's look at the question that we were given. Now we're going to have to look for linear pairs to help us. So it says EBG is 7x plus 11. So EBG, so let me figure that out. E to B to G. Okay, so I'm talking about this rotation between E and G with a vertex of B. That's 7x plus 11. And then EBH, so E towards B to H is this angle. That's 2x plus 7. Now I know it's vertical up and down like that, but hopefully you're seeing that that creates a straight angle. So it is a linear pair. So we can use the concept of the linear pair postulate to write an equation. We can say that 2x plus 7 plus 7x plus 11 equals 180 degrees. So we're using those expressions they gave us for the angle measure. Now we combine the like terms and we'll get 9x plus 18 equals 180. We'll subtract and balance the equation by subtracting 18 on both sides, and we'll get 9x equals 162. Now, more algebra, I divide both sides by 9, and I'm going to get x equals 18. All right, well, in this situation, it's that value I got was x. I really need to go back and say, what was the question asking me? It wants angle 1. And I look, and I have to use what we just learned about vertical angles. Angle 3 and angle 1 are vertical angles. Look, they're right across from each other. They form an hourglass. They are congruent. So that means whatever the measure of angle 3 is, angle 1 is going to have the same measure. So I can take that x value and I plug it in to angle 3, or EBH, because angle 3 is another name for EBH. So 2 times 18 plus 7. All right, so 2 times 18 is 36. 36 plus 7, what is that, 43 degrees if my math's right? So that means that the measure of angle 1 equals 43 degrees, and I would probably go ahead and box my answer to be clear about it. All right, so those are two very important special angles that we learned. There's a couple more. So complementary angles. Those are two angles whose sum is 90 degrees. Okay, so that's the definition. Two angles whose sum is 90 degrees. Supplementary angles, the definition, two angles whose sum is 180 degrees. Notice the difference. Complementary, 90 degrees. Supplementary, 180 degrees. All right, so how are we going to use this? So basically, if I say to you, we're talking about supplementary angles now, okay? If the measure of angle A, or if angle A is 40 degrees, what is the measure of its supplement? Well, if they add up to 180 degrees, we can say 180 minus 40, which is going to give me 140 degrees. So 40 and 140 are supplementary angles. All right, now what if I tell you that the measure of an angle is x? What's the measure of its supplement? Well, we can use the exact same concept. In this example, we did 180 minus the angle. So in this case, I'm going to do 180 minus x, and that's going to give me the supplement. So if x is the angle, then the supplement will always be 180 minus x. That's important because these are the types of questions we're going to be dealing with. The measure of an angle is 3 times the measure of its supplement. Find the measure of an angle. All right, so the first thing I always do is I write something called a let statement. Your teacher may or may not have taught you this in algebra. I look at the question, it says find the measure of the angle, so I'm going to let x equal the angle, okay? And I also am going to be dealing with the measure of its supplement, so I'm going to let 180 minus x equal the supplement. I write my let statements first, so then I can write my equation. I read the question and I plug in exactly as it's written. So the measure of an angle, x, is means equals 3 times, so 3 times the measure of the supplement, which is 180 minus x. Now, since 180 minus x is an expression, I have to put it in parentheses. All right, so now I'm just going to do the math. So x equals, I'm going to distribute my 3 and get 540 minus 3x. I'm going to balance my equation. So I'm going to add 3x to the other side. So I get 4x equals 540. And now I can divide by 4. And if I divide by 4, what does that give me? 4 goes into 5 once, and then 14 goes in 3 times. I'm left with 20, so 135. So the angle is 135 degrees, and then 180 minus 135 would give me the supplement to be 45 degrees. All right, now we are going to be practicing this in class, but this is just kind of a basic overview of it. Now let's look at complementary angles. Again, complementary angles, we said, were two angles whose sum is 90 degrees. All right, so if the measure of angle A is 2y, what is the measure of its complement? So just think back to what we did if it was x. In the other one, we did 180 minus x. So in this case, we would do 90 minus 2y. That would be the measure of the complement. All right, so now here's another one of those crazy questions. Find the measure of an angle that is twice as large as its complement. So we're trying to find the measure of an angle. So we're going to let x equal the angle. All right, the complement of that angle would be then 90 minus x. That would be the complement. All right, now we read the question as it's written and we write an algebraic equation. Find the measure of an angle, so x, that is, so equals, twice, so 2 times the complement, which is 90 minus x. All right, and now we go to use that algebra that you learned so well last year. So we distribute R2 using the distributive property. So x equals 180 minus 2x. I add 2x to both sides, and I get 3x, I'll come over here, equals 180, so x equals 60. All right, so the angle is 60 degrees, and the complement 90 minus 60 is 30 degrees, and yes, the angle is twice as large as the complement. All right, guys, that's it for today. Have a great night.